Okay, we've got this system, this augmented matrix, and in the preceding we saw how to reduce everything down to this stage. And we're in the process now of moving to the next stage. We have a 1 here, which means that by adding 5 times this row to this row, we can get a 0 here. Remember, we want to get we've got a 1 here, we want a 0 above and below. And then by adding -1 times this row to the first row, we can get a 0 up here. So that's the operation we're going to do. Now we do that, of course, with the equation also. If we subtract the second row from the first, we're going to get x minus 0x, which is just going to give us x. And we're going to get y minus y, which is going to give us 0y. And we get z minus, now we're subtracting, and we're subtracting the 6z, so it's z minus a negative 6z, which is going to give us 7z. And 1 minus -1 is 2. Operating on the third row of the preceding matrix, we add the third to 5 times the second. Of course, 0x and 5 times 0x is still going to give us 0x. -5y plus 5 times second row, 5y, is going to give us 0y. And z minus 5 times -6z. Now 5 times -6z is -30z, and minus 5 times -6z is then going to be plus 30z, which will be added to that z. So we're going to have a 31z, and that's going to equal what? -6 minus 5 times -1. Well, minus 5 times -1 is plus 5, and a -6 is going to give us a -1. Now let's do the same calculations using the augmented matrix. Okay. Let's do the third row first. 5 times 1 is 5, and I was doing minus 5 times the second row, and it's plus 5 times the second row, so I have to fix that. Okay, the 0y was okay here. We're adding 5 times the second row to the third, and so we add 5 times the second row to the third here. On the z's, that's going to give us -30z plus z is -29z. And then 5 times the second row, we've got a -1, 5 times that is -5, added to -6 gives us -11. Okay, now, over here, again, the third row, again, we're doing third row plus 5 times the second row. Third row plus 5 times the second row, well, that's just zeros, so we get a 0. The -5 plus double, and -5 plus 5 times the 1 gives us 0. And the 1 plus 5 times -6 gives us 1 plus a -30, which is -29. And -6 plus 5 times -1 is -6 plus -5, which is -11. Now the first row, we're just going to do the first row of the previous minus the second. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus a -6 is 7. And 1 minus a -1 is 2. Now let's make sure our coefficients here agree with what we have over here. Okay, it looks like everything agrees, so it looks like we're okay. So this is the system at this point. What do we have to do next? Well, we're going to need a 1 down here, and we're going to need zeros here and here. Okay, now we have the system and the augmented matrix, which say exactly the same thing. What's our next step? What we're wanting to get a 1 here and zeros here. Alternatively, we're trying to eliminate the z term here and the z term here. If we eliminate the z term here, then our 0x plus y and a 0z is going to give us our value of y. If we eliminate the z here, get a 0, well, just eliminate the z here, we'd have a 0z, so we'd have x equals whatever this number turns out to be. So what are we going to do? Well, we're going to take our third row divided by negative 29, or our third equation divided by negative 29. Okay, so third row of the preceding matrix is this. We divide by negative 29, we get 0, 0, 1, 11, 29ths. And of course, our first two rows are unchanged. Now we do the same thing here. We get 0x plus 0y plus z equals 11 over 29. And our first two rows remain the same as before. Okay, we need only one more step to finish. Can you see what that step would be? Again, we want to eliminate the z's here and here, or equivalently, we want to get a 0 here and a 0 here. Well, I'll observe, if we multiply if we add 6 times the third row to the second row, that's going to give us a 6z to get rid of that negative 6z. And since we have zeros for the x and y, it's not going to change the values or the coefficients of x and y in this equation. Of course, it's going to change this number. There's going to be a fraction involved, but we can deal with that. And if we then subtract 7 times the third row from the first, that will eliminate z and give us a result for x. Alternatively, add 6 times the third row here to the second. We're going to get a 0 here. That's what we want. Add negative 7 times the third row to the first. We're going to get a 0 here. So I'm going to, well, let me write out what we're going to do. We're going to take the first row, minus 7 times the third. We're going to take the second row plus 6 times the third. And then the last row we're going to leave alone because our last row already gives us the solution for z. It's 11 over 29. Okay, well, first row minus 7 times the third. The only thing that's going to change on the left-hand side is we're going to have a 7z minus 7 times z. That's going to give us x plus 0y plus 0z. But what's that going to equal? Okay, 7 times the third row, or negative 7 if you wish. Negative 7 times the third row is going to be 77/29. And of course, we're going to have to add that to 2. So it's going to be 2 minus 77/29. Well, 2 is 58/29. So we're going to get 58 minus 77 over 29. Now, if you're not comfortable with fractions, as most people aren't, you're going to have to maybe sit back and work that out. It's going to be 2 minus 7 times 11/29. Okay. Now, arbitrarily, this is the same thing we would get if we did the operation to the augmented matrix. Now, 58 minus 77 is negative 19. So I think we get 1, 0, 7, negative 19 over 77. Again, if we do the same thing here, negative 7 times this added to this gets rid of the 7. And I didn't get rid of the 7, did I? Should be a 0 there. And negative 7 times 11/29 is negative 77/29. 2 is 58/29. 58 minus 77 is negative 19. So we have negative 19/77. If my arithmetic is correct. Remember, I allow myself to make mistakes here. I don't just allow myself, sometimes I can't help it. But okay. Now over here, we're going to add 6 times the third row to the second. And we're going to get clearly 0, 1, 0. And then 6 times 11/29 is 66/29. Negative 1 is negative 29/29. And negative 66 minus 29 is 37. Negative 37. So I believe we get negative 37 over 29. Over here, same thing, we're going to get 0x plus y plus 0z. How did we get that 0z? We added 6 times the third row to the second. Zeros here didn't affect what we had for the x and y. But now we're going to have to add negative 6 times 11/29. Oops. That was, no, we're going to have to add 6 times 11/29 to negative 1. And in doing so, I believe we get negative 37 over 29. And then we have our 0x plus 0y plus z equals 11/29. Finally, we then have x equals negative 19 over 29. And it's not negative 19 over 77. It's negative 19 over 29. I'll go off camera and fix that. Okay, I've made that correction. And now I've just written down what these equations tell us. I've simplified the 58 minus 77. But we get x equals negative 19 over 29, y equals negative 37 over 29, z equals 11 over 29. And of course, this reduced matrix gives us exactly the same information, x and nothing else, equals negative 19 over 29, etc.